Halo teman-teman, kali ini aku dan Mantan berbicara tentang kecerdasan buatan dan perannya di masa depan. Cuplikan pembicaraan ini sudah pernah tayang di series YouTube kami bernama Watch Right Weekend. Di sana, kami membahas peran kecerdasan buatan dalam menghadapi perubahan iklim. Di podcast ini, kami menyelam lebih dalam tentang prinsip kecerdasan buatan itu sendiri. Simak pembicaraan kami. Oh, tapi sebelumnya, bantu kita cari duit dulu ya.
Kesulitan yang biasanya dirasain waktu kuliah di Belanda adalah ketika orang rumah di Indonesia mau kirim uang ke Belanda. Uang yang digunakan sangat penting untuk biaya kita kuliah maupun kebutuhan kita sehari-hari. Namun sayangnya di situasi seperti sekarang, kirim uang nggak semudah yang dikira. Bahkan membutuhkan proses yang lama. Untuk itu, Transfest hadir sebagai solusi untuk kamu yang ingin kirim uang ke Belanda dengan cepat, aman, dan mudah. Uang dapat diterima sehari setelah hari transaksi, dan biaya admin yang murah, yaitu 74.000 saja untuk setiap transaksinya. Selain itu, tidak ada hidden fee yang dikenakan setelah kamu melakukan transaksi. Gimana? Oke kan? Juga, kalau kamu menggunakan kode referral PPI Belanda 898473, kamu akan mendapatkan gratis biaya transaksi pertama kali. So, tunggu apa lagi? Yuk, gunakan Transfest dan rasakan sendiri kemudahan kirim uang ke luar negeri. Transfest, cara paling mudah dan nyaman untuk kirim uang ke mancanegara.
Untung, like it's a good thing we checked. So, tadi how did I start? That was so good. So hi Mantan. Hi. So this is just like a normal investigative. Like I've told you before, because this is our second take by the way, because we lost the first one. But yeah, we did this. We're doing this investigative journalism thing of like explaining climate like theory and narrative, a different climate theory narrative in Indonesia and in the Netherlands, and we just sort of like compare and contrast about it. But like at one point, through like during this process of like journalism or whatnot, I encountered like a quote from like our Minister of Education technically. But before he was the Minister of Education, before he was like a startup co-founder, and he speak how AI can solve like environmental issue or climate change issue, and I was like pretty skeptic about it because like yes he's a Harvard guy, but he doesn't have like any technical background about it, and I was like. Yeah, I was like, are you sure that it's that easy? Because like he was like pretty like convincing, about how AI can solve climate change. But then like over a coffee, like you talk about how enormous the problem really is and how complex the dilemma of exploiting like resource or like allocating resource to the climate change, like through the approach of AI. So yeah, but like before everything, can you like introduce yourself? I hope it's running. It is running.
Okay, that's very nice. Hi, I'm Mantan. I'm a second year bachelor AI student at Radboud here in Nijmegen. And I've started becoming more interested in like the climate crisis issue at hand because we've been discussing a lot about it, even like throughout our courses. And generally when we discuss the societal impact of the kind of technological development that we're also studying.
Right.
And there's a lot of complexity and nuance there,
right.
like you said. Right. So I've also taken a course, like an elective course, that's discussing specifically the climate crisis in an interdisciplinary manner and talking about the different facets of the problem as a whole. And to give the 50 or so students that are doing the course a decent idea about how all of the different disciplines and fields contribute to tackling, but also in some ways causing the climate crisis as a whole, because it's not a complete binary thing. You're either contributing it or you're helping solve it.
Right.
But all of the fields and disciplines fall on a spectrum, wherein you're also causing it to some extent while you're trying to solve it.
Right.
And AI very much falls on that spectrum as well.
Right.
So like your Minister of Education talking about how AI will solve everything.
Just like specifically climate change.
Yeah, like everything when it comes to like the climate crisis
change.
problem.
Yeah.
Personally, I think that is a sentiment that is shared in a lot of situations,
Right.
not only like the climate crisis
Right. Yeah.
with AI coming in and solving everything, but
because they're hoping for like a super intelligent computer, technically.
Yeah,
that
yeah.
can solve all of our problems.
yeah,
but that's not the case.
but what we have with AI now, technically, is just fast computers doing clever statistics.
Right.
But when it comes to the climate crisis, AI can be very helpful because, again, if we have a tool that's going to help us study big, massive data sets
Right.
and trends and tell us, okay, so this is all that we've seen in the last 50 years, for example, and these are the trends that are being followed, because a human being can't just like look at a table of data, and it's not simply just graphing it, but it's graphing like high dimensional data because you have so many different variables.
Right.
And
so
it's
it's not just like X and Y, it's like X, Y, Z.
And X1, X2,
Yeah,
X3,
right.
YZ, Y1, Y2. Yeah, it's massive data sets because I'm collecting data about temperature, precipitation, rainfall. I'm collecting data about where, for example, wildfires occur, how frequently they occur, what happened before the wildfire, what happened after the wildfire, what happened like 3 years before the wildfire.
Right.
Like in this, what's happening, like if Australian wildfires happen in January, what's happened every December for like 50 years now.
Right.
And I'm going to try to use that data and sort of predict what December next year will look like, what December the year after that will look like,
Right.
and if that will lead to like what kind of wildfire situation you may be looking at in January.
Right.
It can predict the frequency of these things and how intense they might be given the current situation. What does the weather data currently look like? And comparing it to what it has looked like for the last 50 years, for example, and then predicting, okay, given everything that's happened in the last 50 years, this is most likely what will happen now. Okay, and if this is true, that's what will happen next year. And if that is true, that's what will happen next year.
Right, right.
So there is some truth to like AI systems and machine learning models and neural networks and all of these fancy buzzwords being like real technologies that actually help
Right.
to some degree, to like a decent, to a better degree than almost any other tool we've had so far. But it helps to be realistic because this isn't going to solve the whole problem. All it's going to do is like predict what might happen, and then you still need human beings to look at this information, be aware enough of the restrictions at hand. What resources do I have available? How much can I ration? How much can I deploy?
Right.
And you need human beings to make these executive decisions in most cases. And that is probably not going to change very soon. But in the same class that I was talking about, one of the assignments we had was to talk about the subject we're studying and how it relates to the climate crisis.
Right.
And the question was very open. So I went into it with like, sure, I've generally heard that AI will help. But then I very quickly came across a lot of discussion of how AI systems tend to be so complex because, sure, these are very clever statistical and mathematical models we're running, but they're very, very big, complicated algorithms and models. Yeah. And we're running these on extremely massive data sets.
Right.
For one of, like, data sets that are...
Have like millions of tables, right?
Yeah, so there'll be like a few terabytes each. That's a data set.
Right.
There is...
Do you know, okay, do you know how much like bytes is one column of Excel sheet, perhaps?
I know.
You don't, okay. Okay. Because then, you know, you can see the whole scale of like
No,
terabytes.
but it's... So I did an assignment in which a very common data set that's used for like training things is the million song data set. And it has 1 million songs, and each song has like 300 descriptive attributes about it. So the length of the song, the year it was, 300 things about the song.
About the song.
So 1 million songs, so 1 million rows, and 300 columns.
Columns, yeah.
And that data set only is like 40 gigabytes.
Okay, now you can see.
Yeah, and that's a million. That's 300 million data entries,
Right.
and that's about 40 gigabytes.
Okay.
And I couldn't download it because it was that
Too
massive,
big.
and it would on my computer.
It would smoke your computer.
I would need like 6 months to run my model, my very, very simple model, which I basically just need like one line of code for to run it on that whole data set. I would need like a few months.
Okay.
But now we're talking about like extremely complex algorithms
Then now you know
On-
the scale of it.
on data sets that are like a few terabytes
Right.
in size. And I came across a very interesting thing wherein like machine learning models and neural networks that are run on average size data sets. So a few terabytes would be like maybe average, very many terabytes would be extreme,
Right.
but like still a few hundred gigabytes, for example, like an average data set on a supercomputer. Because a lot of like, if I was a startup, an AI startup, and I wanted to train, for example, a speech recognition model, I would create like a natural language processing algorithm. And now I have my data. For example, I have like all of these hundreds of gigabytes of data, and I have an algorithm, but I need computers to train it. So then you can always hire supercomputers and like all of those that are available, like like Google, Amazon, and Facebook. Largely, the big three companies that have the resources that rent it out for me to like run it on, and then I will just get the final results. But running like average natural language processing algorithms, like some of the most common ones on data sets around these sizes, will emit, just because the computer needs so much power, like electricity, to like run all of
the cooling system and everything.
The cooling systems, and plus also just running the processes and stuff and all of those things.
Right.
Running it on like one model, training one model one time, and you almost never train it just one time because you need to do it a few times.
A few times, yeah.
Will emit about, like, will emit enough carbon to amount to like 140 flights between London and New York.
Okay, shit.
And that's 140 flights.
Right. For how many gigabytes that is?
Just like a few hundred gigabytes, maybe like something like that. So it's going to emit a lot of carbon just running the model.
Right.
Yeah, and that's running it once. You're going to run this multiple times. So again, it falls on that spectrum wherein yes, it's going to be able to do a lot to help, but you have to be careful and like clever about how you allocate these resources, because it's also
like
energy.
Impact, right,
It's energy intensive. It's
Really?
going to require a lot of power and a lot of time, and it's going to contribute to
emit like more greenhouse gases. And
yeah,
everything, right?
yeah.
Right. But that is interesting though. But like what I'm interested in, that shows like how it's not as like, you know, as clear as it is to like as they speak it, as the politicians speak it, right?
No.
Because like they would just like use this buzzwords, and you know, like their voters will think like, oh dude, this guy's smart, maybe we should vote for him, right? But that's not the case, because like it's way more complex than that is. But what I'm more interested in is like, because like I'm doing just normal statistic, unlike you do. I'm like pretty good in R, just like the R code language, but like our data set is not as big as the one you described.
Oh, I didn't use that. I used like a 10% subset of it because I couldn't run it on my computer.
Right.
Yeah.
But like you will probably face it like if you like dive into AI like in the future, right? But like like in statistic, like the one sin in statistic is extrapolation, right? Technically, like what I was told about, what I was taught, like in the past. For me, AI is just purely extrapolation, because but how is it justifiable to like trust this model when it just run on extrapolating data set from the past to the future, where it projects in a situation that we don't even know? Like how do you like justify it?
So I think the difference here would be that you're running extrapolation models that this isn't like really a justifiable answer, but it seems to have worked so far. I haven't
more?
No, yeah,
Right.
perhaps, but I haven't really thought about it as much. That's a very interesting point.
Right.
Because I remember coming across that, like, even in school
Right.
and stuff in general.
Like even in IB, right? Like
Yeah.
in statistic, like in IB, you can just like write extrapolation and you can justify the answer that it's wrong, right?
Yeah, I
Like,
remember
you
doing
remember that like
Yeah.
paper 1 or something.
Yeah.
You can like write extrapolation and it's an acceptable answer, because like,
That's a limitation of like this.
of
thing.
statistic
Yeah,
models. Right?
yeah.
But like for me, AI is just purely extrapolation. Like based on my like surface knowledge of AI, it just seems to be purely extrapolation. But what do you think about it? Like what does it make it different? Is it just
So-
because we play on the probability of it instead of like the exact answer of it? What do you think?
Yeah, so first of all, I think like there'll be a few reasons as to why extrapolation here is more justifiable. The way you'll train these models is that if I have 100 entries, and this is the data that I have,
Right.
I will train my model on like 70 of them, and once that's trained, I will test it on the other 30 to see if it gives me a correct answer. And if it gives me a correct answer like 98% of the time on the other 30, and I expect that my real world data from now on will mostly mimic this data set, then you've technically obtained like 95% accuracy on real world
So it's
data.
like compound probability, right?
Yes.
Okay.
But also it's like the statistical models are complex enough wherein you're taking into account so much more, like so many more aspects than like a single one.
Right.
What example can I give you? For example, if I was taking the song data set, now I'm
Right.
thinking about that.
Okay. Sure.
If I was to talk about like the genre and I was predicting whether it would be in like the top 100 on like a chart,
Right.
yeah, and just I'm only using the genre and I'm using the top 100, and I create like a straight line model, like I just make a straight line predicting these things somehow, because I don't know how you make a straight line with genre. But
Right.
the length of a song and whether it will be on the top 100 or not, and you have like a straight line predicting that. You've only taken into account one aspect of the song, which is the length. But now when I'm using like a very complex model, I will take into account like 30 different aspects of it, 100 different aspects of the song. And so you're backing this up with a lot more information about the test objects.
Right. Right.
Yeah? So it's a lot more thorough, and it's taking into account a lot more nuance.
Right.
And absolutely, before deploying any of this, that's not always the case, but ethically you would expect for developers of these algorithms to like make sure they test it adequately.
So you have higher like accuracy in that sense.
Yeah, so you're mostly maximizing. So making like an algorithm is not the most difficult thing. Like a lot of useful algorithms exist, but the largest part of like training a model, like I said, like even training the natural language processing model, you will probably almost always end up using an algorithm which exists. There's going to be like 8 variables in that algorithm, and you have to find the best, most optimum value for that variable.
Right. Right.
Yeah? And that's what I'm training it on. I'm training it like that one algorithm on this data set, for each variable, I will give it a range of values. Like start from 0 and test between 0 and 300. And it's going to try it for variable 1 between 0 and 300 and see which one's the most accurate. And it will do that for all of them. And then it will give you the combination of like maximizing accuracy across the whole thing.
Zero, like the one you say, like 0 to 300 is like the accuracy of the...
No, it's, I will give it a range of values. So for example, if I have like an equation which has a squared plus b plus c gives me the final output. Like, for example, like I have 3 things here that I'm taking into account, A, B, and C, and it's going to try to predict what number on the top 100 chart the song is going to end up on. I'm going to run this. I'm going to say A can take values between 0 and 300.
Okay.
B can take values between negative 25 and positive 25. C can take values between negative 1 and 1. Right? For example.
For example.
And then I'm going to run this model on all different combination possibilities and then try to maximize accuracy of the final prediction.
Right. Yeah. Okay.
Yeah, and I'm not just like
So you're just
randomly
changing-
predicting the accuracy. I'm going to like do that on a test data set wherein I have like songs from the last 60 years and I know where on the top 100 chart they ended up. But I'm going to keep that like that last information away from the model.
The model, yeah.
And then I'm just going to like tell it to give me a prediction and then compare it with the actual data.
The actual one, right.
Yeah, and then see how accurate was this.
Fuck, okay.
Yeah, so maybe this was like accurate. The first time it was accurate like 70% of the time. The second time it was accurate like 92%, then 98% of the time.
Right.
And wherever it maximizes, that's largely where you will. Those are the values that you will take into account and start using.
Right, okay.
Yeah.
Sorry, I was burping. Okay, then it makes sense, because like now, like if you think about it, like the knowledge of an artificial intelligent like system is kind of different from like a human one, right? Like human, like they can use reasoning. Like in AI, if you're using AI to produce knowledge, then you're just trusting the model, and like as like you're just trusting the model based on the accuracy it provided you, without actually being able to know how they get that value. But then because of the higher success rate, then probably it's right. Like 90, like you say, like 95% of it is right. So like
it was right 95% of the times on the test data.
Right.
But now it's difficult. It's tricky to be sure that my test data is perfectly representative of the data that I will encounter in the real world.
Right.
That's a whole other problem.
But then because like I don't really know anything about AI. Like it has always been like just like a buzzword for me. But now I know like let's go back to TOK, right? Like in TOK, to justify what is right, because like knowledge is what you can justify as right? Like human, they can use like natural language to like give reasoning to explain why A is right, perhaps. If you use AI to produce knowledge, you just say that this model's 95% of the time it's right. It's like
so
sort of.
So
like
there's a 95% chance that it's right now also.
Okay.
That's largely what you're getting to. But so that's a whole issue with trying to create models which are explainable, because now at this moment these models are so complicated that no human being can actually understand them. Like it's taking into account like 3 million rows with like 1,000 columns each, and it's creating like a very complicated model from it, and it's basically like a black box. Information goes in and information comes out, and I don't know what it's doing in between. I don't a human being simply cannot understand what's going on inside.
Yeah. Before they went insane, probably.
Yeah. And so there is a whole issue with trying to create AI systems which are explainable. So either you figure out a way for this model to have enough natural language capabilities, when it can explain in simple natural language what it's doing.
Yeah, so, right, so
But,
it could
yeah.
not infer causality or causation. It can only give you correlative, like
Relationships, like correlation only.
Right, only correlation
No,
technically.
no.
Okay.
So the inferring causality still falls on human beings. So like the example with like the peatland fires, the model's only going to tell me what is most likely going to happen. Figuring out why this may happen still
Needs human.
yes, still need as of now needs
Right.
human beings.
Please don't. Please don't.
I actually don't think that it'll be very soon that you have computers that can reason, because that seems like a very difficult problem
Right.
to try to approach. To the best of my knowledge, I don't think there is a working framework to try to explain how human reasoning works.
Yeah.
Like there is also a very big problem of like common sense. How do you like trying to get a computer to have common sense?
is so hard, right?
It's
Impossible.
yeah, it's at this moment
Right.
seemingly impossible. Like there's so much work being done to there, but like, so do you just like create a list of common sense rules and like feed it into the computer that if you throw something up, it will come down? If you want to make sure something doesn't fall, you have to place it on a surface that won't fall. And how do I know that this surface is stable? And like, there's so many like small facets. I think there's a person that's actually working on like compiling a list of common sense facts. And he's been doing that since like the 80s.
Dude, honestly speaking, I need to read this list because sometimes my common sense just fail me.
Yeah. It's like it's a list of like a few thousand just facts, and maybe that will help.
Right.
But these aren't things that you can like have a model learn on its own.
Right.
It's maybe you could, but it seems like a very daunting task to be able to figure out what humans seem to know intuitively, or if they don't know intuitively, they're able to like grasp very easily and very quickly. But a computer seems to need
Their own time, like
a lot more
repetition.
and training, and so many more examples to learn on.
Right.
I remember coming across this example of like in our introduction neuroscience class.
I'm doing that, by the way.
Brain.
I'm doing neuroscience. Yeah.
Oh yeah.
Hopefully.
Yeah, that'd be cool. But yes, our course is just called Brain. It's really funny.
Right.
The teacher came up with an example wherein there were like random shapes, and it was just like randomly drawn shapes. And the slide before that.
What happened, shit? Is it too hot?
Did it switch off?
Oh shit.
Did it switch off?
Okay. So like yeah, it has been a really fascinating discussion because like now, like I know how how AI works, right? Because like
To some degree.
to some degree, like obviously I could not make a model myself, but at least
I don't know if I can completely do it myself yet, but yeah.
Yeah, hopefully you will be able to do it
By the end of my bachelor
degree. That was what I was saying.
Yeah.
Right.
For my thesis, we will hope.
Right, hopefully. But now I know the cut off between like human capability and artificial intelligence capability, right? I think like human can employ artificial intelligence to the extent of guidance, you know, like to where do we look for clues, where do we look for information, but to process the causality or like the logical flow of it, flow of the like the explanation of the information still needs a human.
As of now,
As
yes.
of now, right.
As of now, yes. And
Right.
I personally, again, don't think that it's going to be very soon that humans will be replaced in like their reasoning and logic aspect of it. But so far, yeah. And also, like, I think it's very important just to like reiterate, AI will help, but it's not the only solution. Google, like with their server farms and their supercomputers, can start making them like sourced with renewable energy, but like that only helps to some degree.
Right, right.
There's still so much that even simply running these models contributes, and it would be nice to like have a more realistic outlook on how much this can help, because it can help, but it's not like the end-all solution to everything.
Right. Okay, I think
Yeah.
we should end it.
Yeah.
Okay, thank you so much.
Cool.
Bye-bye.
No problem.